Okay, so this video is going to cover section 5.7, which is triangle midsegments, and trapezoid midsegments, I guess. Here we've got the homework or the practice from last time. If you want, these are all proofs, so there's really no answers specifically, but if there's some that you would like to go over, of course, let me know, and we can talk about maybe one or two of them, make a video or something. So today we're going to be talking about properties of midsegments. We're going to define those and then cover the properties. These properties are pretty intuitive, and so not too much. Definitely a lot easier than the proofs for sure. So just a couple of things coming up here. Friday is going to be our last quiz of this chapter. There's going to be two proofs on it. One is going to be a little bit easier, and one's going to be a little bit harder. Nothing like the ones that I did for those of you that are in class, the ones that we did the second day. Those are kind of on that hard level. That's ones I wouldn't expect most people to be able to do on their own at this point. But one easier one medium one, just to kind of see where you're at. And then next Tuesday, a little less than a week away from today, you're going to have a chapter test. So first things first, what is a midsegment? We talked really briefly about these, probably first try sometime, but a midsegment is the segment that connects the midpoints of two sides of the triangle. So if you take a midpoint there and a midpoint there and connect them, that blue line is called a midsegment. Now a triangle is going to have more than one midsegment. You also have a midpoint down here. If you connect them, you're going to end up with a total of 3 midsegments. Now in a trapezoid, a midsegment has just a slightly different definition. You're only going to connect the midpoints of the two legs, the non-parallel sides. So you've got midpoint there. That's a midpoint or a midsegment. There's only one of them in a trapezoid. Okay. So let's take a look at what we know here. I'm going to guess you'd probably have some ideas about this. First thing here, if I go ahead and make this. Loading, there we go, is the length. So if you take a look at this triangle here, we've got our side here is 10.6, our midsegment here is 5.3. It is exactly half of the side. Now if you'll see, if I change this around, except for some rounding errors that happen somewhere in here, you're going to see that it's always half. There you go, half. No matter what I do, the midsegment is always half as long as that side is. Now the other thing you want to notice here is those two lines are always staying parallel to each other. So the things that we've got to know about the triangle midsegments is that a midsegment of a triangle is parallel to the third side and half the length of the third side. I can spell. There we go, half the length of the third side. So those are the two things that we know about triangle midsegments. They are parallel to the third side and they are half the length of the third side. And that is always just the side that they're parallel to, the one they don't actually touch. So you're going to see questions like this. It says DE is a midsegment. It's telling you it's the midsegment. It might not tell you that, but it might have the marks that show you that D is the midpoint. That'd be a good way to look for that. And it's saying find the missing angles in the figure. Well, the big thing is if these are parallel, then we get to use things like corresponding angles and alternate interior angles. So 70 and this angle up here is its corresponding angle, so it also has to be 70. We can use linear pairs here. If I got 70 there, I have to have 110 down here. Same thing with the 33. I can use linear pairs. So I'm going to have 147, I believe. Oops. 33 and angle C here is a corresponding angle, so those 33. And then to find this last one up here, I can use my triangle sum conjecture, either using this little triangle or the big triangle. It doesn't really matter. But 70 and 33 is 107, so we have, what would that be, 77 left for our last one. Then it says the perimeter is 25 meters, and we're supposed to find AC. Well, the big thing here is because this is a midsegment, if this is 3, so is this. And if this is 5, so is this. So for the sides that I know, this side is 10, this side is 6, so I know 16 total, and it's supposed to add up to 25. Well, I can just take 25 minus 16, and I get 9. So AC has to be 9 meters long. So you'll see questions like that. Next up, if we draw all 3 of the mid-segments in, you're going to notice hopefully something, and that is that the triangle here gets divided into 4 littler triangles. And let's take a look at what we might notice here. There we've got our 4 little triangles, and I want you to see something here. So what you're seeing is that all 4 of those little triangles are exactly the same. They are all created by being half as long. Each triangle has half the lengths of the sides of the other ones. So for example, DE is half as long as BC, and so is BF. BF is just half as long. So that side, and that side are all equal. That side, that side are all equal, and then that side, and that side are all equal. So by SSS, all 4 of these triangles are the same. So you might see some questions like that, where if I tell you that this side, can't click on that, can I? If I tell you that this side is 10, the whole thing, and ask you what DF is, well, that would be 5. If I told you, maybe I gave you that, I don't know, that this piece here was 4, then that piece would be 4. Or if this angle was 30, then so would that angle be 30. All these triangles are equal, just remembering that DEF is kind of turned 180 degrees from all the other ones. Finally, we've got our trapezoid mid-segments. And so we're connecting still the midpoints of the 2 legs. And hopefully you probably noticed from that picture, it does still look like it's parallel to the other 2. And if I go back to here, you're going to see. So this is a proof here. If I take my trapezoid, flip it over, and draw in double the mid-segment, you're going to see that double the mid-segment is equal to the sum of the 2 bases. And so this is just a proof of figuring out how long this mid-segment is. The mid-segment of a trapezoid is still parallel to the bases. Parallel. And it is equal in length to the average of the bases. So I'm going to take the average, find the number exactly in the middle of the 2 bases, and that's what my mid-segment is going to be. That's how long it's going to be. So you might see something like this. We've got angles. We've got some sides to find. We start with the angles. These are going to be found using things like corresponding angles. So if I have 50 here, well, y also has to be 50. I'm finding something like x. Well, here's 110, so the corresponding angle is here, but I can also still use the properties of trapezoids. Those 2 angles have to add up to 180, so this one has to be 70. Now to find the middle lane, the length of the mid-segment here, this is where I'm going to take my average. And averages, remember, are just found by adding up the 2 sides and taking that number and dividing it by 2. And so here, 12 plus 32 is 44. Divided by 2, we get 22 for Z. Now, there's one last question I want to go over here before I show you the practice I want you to do. That's something like this. So here I know the mid-segment and one of the sides, but I don't know the third side. So I want you to think about how you might be able to solve that one. Okay, now there's 2 ways we could do this. The way your book is always going to show you is we should use some algebra. I know that 15 plus x divided by 2 has to equal 18. And that's an equation we can solve. We can multiply both sides by 2. And we can subtract, oops, it's supposed to be an x. And we can subtract 15, and we can get x is 21. Now, most of you are probably not going to do that. It's a little more intuitive way. We know that this is exactly in the middle. So if I look here and say, oh, well, that's just 3 bigger, what do I have to do to get down to there? Well, I'm going to guess I'm going to have to add 3. So 18 plus 3 is 21. So most people go with something more like that. But of course, if you wanted to, you could do the algebra. Okay, and then our practice for today. We're going to do page 307. This is 1 through 8 and 13. I'm just going to kind of scroll through this page. If you would rather just look at this video and kind of pause it at the right spot to do the practice, you can certainly do that. Number 8 is a proof, so give that one a shot. You have to at least try it. And then number 13 again, look at that picture. Think about how could you measure the distance between the two trees even though the cabin is in the way. Okay, so I will post answers to these probably tomorrow. And there will also be a review worksheet posted tomorrow for you to practice for the quiz.